High in the Swiss Alps, a proof-of-concept project at the Tsarmine Rock Glacier demonstrates how autonomous drone systems enable natural hazard monitoring. Operating fully autonomously in a remote alpine environment, the drone collects high-precision data to support research, risk assessment, and public safety. This project was led by Altron AG in collaboration with Drone Harmony, SkyMap, Fieldwork, and other partners. But what did this project reveal? Let's hear directly from Jan Bengtsson at SkyMap.
Can you briefly explain what SkyMap's role was in the proof of concept at the Tsarmine Rock Glacier?
Our role in that project was to take the collected data and turn it into decision-ready 3D insights, like the 3D models, orthomosaics, and point clouds. And by doing that, we were able to enable clear and good decision-ready material for both technicians and decision makers.
SkyMap has a long experience with 3D geodata. So how does this project connect to what SkyMap does overall?
I would say it's a direct extension of our actually core business. It's the same workflow, it's the same data. The biggest difference is the environment, which is a little bit more challenging than a construction site.
What made SkyMap want to join this project, especially in such a challenging alpine environment?
I would say it's, as you mentioned, the environment. It is a challenging environment, and it's all about proving that the workflow and it works as a robust system, not just as standalone solutions. You got the dock, you got the Drone Harmony platform, and then the SkyMap data processing platform as one workflow.
Yes, as you said, this project combines several partners and technologies. Can you explain how the workflow between the dock, SkyMap's 3D tools, and Drone Harmony's mission planning actually works, and what benefits this complete solution gives to customers?
Yeah, the DJI dock, it provides the hardware, and it's a robust system as a standalone. It has been proven to work in harsh environments before. And then Drone Harmony is the perfect platform for any type of mission planning, and especially with a specific one with the high slopes here. And then as soon as the Drone Harmony platform has made the flight or completed the mission, it sends the data. In this project, it is the pictures and the photos. And then as soon as we collect the photo at our platform, our automated pipeline to create the 3D insights is starting. And then we produce reports and output data. Mm-hmm. And that clearly generates great visualizations for the decision makers. So
from your point of view, Jon, why are stationary drone systems like the DJI Dock 2 so important for natural hazard monitoring in the Alps?
I would say it's all about being at the right place at the right time. So if you have these docks installed in the right place, it helps you to collect data over time, so it's comparable, and it's also makes it possible to have it instant if something special happens. And you don't want to have people in this kind of area if something is about to happen.
What advantages do autonomous flights offer compared to traditional manually flown inspections?
One of them is the frequency. You're able to, by using the same condition on each flight, you can monitor and you get very good results from that. And another aspect is that you don't have to have people on site. You can have the people in a safe place in the office, and the hardware can do the job in field. So it's a very good thing with the safety, of course, and then also to be able to generate that good data with the same conditions each time.
So SkyMap specializes in 3D visualization. What kinds of insights were you able to get from the data collected during the proof of concept?
Yeah, we could clearly see that there are movements, and since we were able to collect like 2,500 points per square meter, you can really see the smallest of changes that can, in the next step, produce more hazardous areas than by just having these selected points all over the area. But now we can really see the details. So there were movements, and we could clearly see it during this time.
Why are accurate 3D models so important when monitoring permafrost areas or places at risk of landslides?
Because there can be the slightest changes in that type of area can in the next step generate a landslide or something like that. So by using the high detail 3D model, it's easier to see both for the technicians and the decision makers.
So how do you see the future of fully autonomous drone solutions in natural hazard monitoring?
I would see it like monitoring as a service, where you have these dock solutions placed in selected areas, where you have like a close range to different areas that you already know is hazardous. And by doing that, you can reduce a lot of risk, both for the people that don't need to be there, and also take good decisions before things happen.
So in one sentence, why do we need autonomous monitoring in the Alps?
To reduce the risk for people being on site and also living near to them.
How does a digital twin change decision making for authorities?
I would say it's all about visualizations. Sometimes it's very easy for the technicians to take the decision because they do this on a daily basis. But for the decision makers, it needs to be clear, and by having the 3D model and digital twin, it's super clear. It's like you're being there and looking at it. So I would say that that's the most important thing by having a 3D model, which is highly accurate.
Displacement measurements of the rock glacier show velocities of several meters per year. By enabling continuous monitoring, autonomous drones help detect natural hazards early and improve public safety. Are you interested in remote drone operations? Visit droneharmony.com.